I'm going to do a walkthrough for exercise 8.4, which is the xZero problem, dealing with 2D arrays. So the xZero problem is based off of a problem that we worked out together last week on our 2D arrays worksheet, and if you were absent or misplaced it, I've put a link here to a key. So you can open that up and see what it looks like. And number 4, if we zoom in, is here. So this problem is based on having to write a method that will take a 2D array, and the precondition is that it has to be an n by n array. So it has to have the same number of rows and columns. So that's essentially a square. And the array itself will hold integers. But what the xZero method that we've called it xZero is that the method has to then transform that 2D array that you pass in so that the elements along both diagonals are going to be 0. So basically you're going to have an x of zeros if you print out this array. So if we take a look at kind of this 3 by 3 array, for example, so you've got a diagonal here along 159 and a diagonal here along 357. Once you would pass an array such as this one, it would have these elements all transformed into zeros. So you have the x of zeros. Okay, so what I've added to this problem is that not only are you assuming that the 2D array is n by n, but you're actually going to initially fill it with just random numbers between 50 and 100, which is based off of number 2 here that we also worked out together. So we're going to have to implement math.random in order to do that. What I'd also like you to do is to print out the original array that you filled with numbers between 50 and 100. Then after transforming it, you're going to print it again. So it may be a good idea to actually create not only an xZero method, but a method to print out a 2D array so that you don't have to repeat the same code. You could just reuse the method. If you have trouble getting started, I've actually added some starter code to get you started. And here's what it looks like. It has some comments in here that has the basic form for declaring and initializing a 2D array. And it's got steps that you need to take in order to fulfill the requirements of this assignment correctly. So let's go ahead and get started. So I'm going to use the basic form of how to declare and initialize a 2D array, which is basically the same way that we declared and initialized 1D arrays. The only difference is that you have rows and columns. Rows and columns. Okay, so we know that the type of values we want to hold are integers, so we're going to go ahead and specify that. And then we're going to go ahead and call this array numbers. And we want to assign numbers a new array of integers with, well, n by n rows and columns, so I'll go ahead and make a 10 by 10. So right now, this array is a 2D array that has 10 rows, 10 columns, and every element is filled with zeros. But we don't want a bunch of zeros. We want a bunch of random numbers between 50 and 100. So how do we access each of those elements in order to change the values? Well, it's kind of like what we did with 1D arrays. We used a for loop. But now we've got 2 dimensions instead of just 1. So this first for loop is actually going to be traversing the rows in the array. So if you take a look at this graphic, it will be going through each of these rows. And in reality, the rows of an array, so if you look at this memory simulation, is an array that stores other 1D arrays, and that's where the actual good stuff is. That's where the elements are held. So we're going to need another for loop in order to traverse each of these elements. which are arrays. You have to traverse another array. Okay, so in order to do that, we're going to have an outer for loop that's going to traverse each row. So int r equals 0 because the rows start at index 0. And we want to go for the length of this row, or the length of this array. So r is going to be less than the length of our array, so numbers.length. And we want to visit each one, so we want to increase by 1 each time. And now that we're in this row, we want to iterate through each element of this array, this inner array. So we're going to go ahead and represent this with int c for column. Again, the columns start at 0 as well. So you see the column 0, 1, 2. So, and this time, instead of saying numbers.length, I mean it's fine here since both the rows and the columns, they're the same amount. There's 10 rows, 10 columns. But what if we had 9 rows and 10 columns? Then we want to be sure that we're not accessing the length of the first dimension. We want to access the length of the inner array representing the columns. So I want to say numbers sub row dot length. And then once again we want to visit every column, so we're going to increase that by 1 each time. Now, what do we do inside here? What actual work do we want to do? So now what we can do is we can use these variables, r for row and c for column, to specify what element we want to change. So we're going to say numbers sub r sub c, so that's going to access the element at row r and column c, and we're going to go ahead and change it to some random number between 50 and 100. So we're going to use math.random to accomplish this, and if you recall, math.random returns a double value. So we want to use int casting to get an integer back, and we're going to call math.random that generates a pseudo-random number between 0.0 up to and not including 1.0. So in order to get a number within the range that we want to multiply it by the number of values between 50 and 100, so that's 100 minus 50 plus 1, so that's 51. And then, to make sure that we have the correct lower bound, we want to add our minimum, which is 50. So that'll give us the range between 50 and 100. So assigns value between 50 and 100. Inclusive. Okay, so now we've got an array filled with, oh, I forgot my for. Don't forget your for in your for loop. There you go. And now I've got, my goodness, okay, so C has to be less than the length of this this particular row, okay? All right, sorry, a little bit of a hiccup while talking and coding. Okay, so now what we have here is an array, a 10 by 10 array filled with elements between the values of 50 and 100. So what's next? Let's print it out to make sure that that's indeed what we have. Okay, so what I suggested is that you create a method that will take a 2D array as a parameter and then print out that array so that you do not have to repeat it again in step 5. So the method that I specified is called a print array. And so what we're going to do is we're going to print numbers array. Okay, this isn't going to do anything at this point because we haven't implemented yet. So let's implement this method. So just like what we did up here, we actually want to traverse the entire row element by element by having a nested for loop. So we can actually reuse this code, but instead of our work is going to change, what we actually do is going to change. So this line needs to be replaced. We don't want to assign a value to an element, we actually want to print out that element. So we're actually going to have a system.out print. Let's start with a print statement. We're going to print numbers sub r sub c. So for every element in a given row r and column c, we're going to print it out. Now, right now, if I go ahead and print it out with a print statement like this, it's not going to look like the array we imagine. You know, a nice square with numbers on rows and columns. It's not going to look like a nice table like what we want. It's actually right now going to look like a bunch of smushed together numbers all on one line, and that's really not what we want. Let me illustrate what I'm talking about. So if we go ahead and run this, you got a bunch of numbers all together, not what you want. One step to fixing this is to create a space in between the numbers. Let's try a space. Maybe a tab would be better, but let's see. It's really up to you. And oops, wrong one. So space might be nice. And then what you also notice is that the numbers are all on the same line. We want each row to be on its own line. So how do we do that? Well, the numbers that get printed out are being printed out in this inner for loop. But what you realize is that this inner for loop gets finished for every row. So after it gets finished with a given row, we want to go ahead and print out a new line. So we can feed it a print line statement with no parameter in it to get a blank line. And we should get something a little bit nicer. And it looks like, you know, due to the different numbers that we get, sometimes we get a 3-digit number. The spacing is a little bit off, so it's perhaps better to use our nice tab character, which we can add in right there instead of the space. And that's a little bit better. So you don't get a perfect square when you're using the tab, of course, but you get the idea, and it looks like a nice table. Okay, so our print array method is finished, and we can now reuse it in step 5, making our lives easier. So the next thing that we have to do is to actually write the xZero method, which is the whole point of this assignment. So we actually wrote out the code for this together last week, and it might be a little bit different in our implementation on BlueJ just because we've used maybe perhaps a little bit different variable names, so it looks about the same. So if you recall, we didn't have to access every single element, so we didn't have to make use of a nested for loop because we saw a pattern. And that pattern was that along one diagonal, taking this 3x3 array for example, across this diagonal here going from left to right, top to bottom, you see that this element is at row 0, column 0. The next one in the diagonal is at row 1, column 1. And the next one is row 2, column 2. So the values of the row and the column are shared across this diagonal, so we don't actually have to traverse the columns of this array. We can just reuse the variable that we're using to keep track of which row we're in to access that first diagonal. So let's go ahead and do that part first, and then we'll talk about how we get the element, how we access the element of the other diagonal across that 2D array. So we want to go ahead and just traverse the rows of that array, so accessing the inner arrays. So for r equals 0, and we want r to be less than the length of numbers dot, the length of numbers, which is numbers dot length, and we want to access every row. Okay, so we said that for the first diagonal from left to right, top to bottom, that basically the value of the row is going to be the same thing as the value of the column, so we can reuse our row counter here. So the value of the row and the column are going to be the same. So 0, 0, 1, 1, 2, 2, etc. So we're going to go ahead and set each of those elements to 0, so that we'll get zeros along that diagonal. Now for the second diagonal, we also saw a pattern that wasn't as obvious, but basically the rows are going to be the same, right? You're going to start out at 0 something, so you got 0, 2, and then you move up 1 again to 1, 1, happens to be the same because it's in the center, and then 2, 1. So you're reusing the same rows, but the columns are now different. And the pattern with the columns is that you've got, for the first one, it's the length of this row minus 1, and then the length of the next row minus 2, and then the length of this row minus 3. So you're decreasing, the number you're decreasing by is increasing by 1. And what other number is increasing by 1 as we're going through this for loop? The value of r, right? It's increasing by 1. Now the problem is that r starts at 0, not 1. So that's why we decided that we had to decrease that column value not only by r, so this is basically the column value right here. So we're using number sub r, so the length of that row, minus whatever r is, so it's going to start out at 0, but we want to actually start out by decreasing it by 1. So it's minus r minus 1, so that first time it's going to decrease by 1, the second time it's going to decrease by 2, to 3, and so on. So that's going to get us the correct column value for this diagonal. Okay, so we're going to go ahead and add that line of code. So right under this one, we're going to say numbers sub r, and then the column value is going to be numbers sub r dot length, so the length of that row minus whatever value of r is, minus 1. And that's our column value. So now that's going to give us a particular place in our array, and we want to set that element to 0 so that we get zeros along that other diagonal. So we've created this xZero method. Now we have to use it. We have to call it here as our fourth step. And as you can see, xZero takes a 2D array, so we can pass it our numbers array. And what that does is it goes ahead and transforms the array by setting those specified elements to 0. So now we simply have to print out the array again. So we're going to go ahead and print array numbers. And this might be a little unclear when we run this because it's just going to print out two different arrays right after each other. So to kind of format this a little bit better, what we can do is we can add some print statements to separate these things out. So I'm going to go ahead and say this is the original array, and then go ahead and create a new line here. Just separate these guys out. And then right before we print the transformed array, we can put a message that this is now our transformed array. So now when we print this, it's a little bit easier to read and to see what's going on. So we've got our original array filled with random numbers between 50 and 100. And then we've got our transformed array, and you can kind of see how there's now an X of zeros along the diagonals here.